Here's the next example. Graph 3x plus y equals 10. Now remember, it's just all about finding ordered pair solutions, a number for x and a number for y that would make the equation true. And if you can spot those ordered pairs by inspection, that's still a good way to go. If you looked at this equation and did some mental math to see that if x was 3, 3 times 3 would be 9, and then y just needs to be 1, so that added up it equals 10. 3, 1 is going to be an ordered pair solution on the line. And you could maybe do that a few times to get a few ordered pair solutions. But we will be focusing on a strategy where we solve for y and then make the table. It's going to serve us very well for more complicated problems, and we're also going to see some important reasons in the future why we like to have equations that are solved for y. So that's going to be a focus for the next few problems. Take the starting equation and solve for y to get a form that is very good when it comes to making the table. So how do we solve this equation for y? Remember, that is about not finding what number does y equal, but isolating the variable y in this equation. Move the 3x term to the other side of the equation. The way we do that, take away 3x from both sides. That will isolate the y on the left side, and it leaves us with 10 minus 3x. And that's a perfectly accurate way to write it. But for reasons that we'll see in the future, I want to get in the habit, and I want to get you in the habit, of putting the x term first. Write that first. So put the negative 3x first, and then this is a positive 10, so we're writing plus 10. Both are equivalent, both are great ways to go about solving for y, but we'll see in the future why it's helpful to look at the x term first and the constant last. So our motivation for solving for y was to make the work very smooth when we make the table. So let's do that now. Here's our table, and we're choosing whatever values of x we want. I'm going to start with 0. The equation now is y equals negative 3 times 0 plus 10. We know that multiplying by 0 equals 0. We're only left with that positive 10. So there's our first ordered pair solution at 0, 10, way up at the top on the y-axis. Now I'll choose x equals 2. The equation is now y equals negative 3 times 2 plus 10. That negative 3 times 2 is negative 6 plus 10 equals 4. So our next ordered pair solution is at 2, 4. Last, I'll choose x equals 5. Y equals negative 3 times 5 plus 10. Still the same equation each time, negative 3 times our value of x plus 10. This is negative 15 plus 10 equals negative 5. So that third ordered pair to the right, 5, and then down for the negative 5. Using a ruler, we'll make sure that our 3 points do line up on a straight line. And they do. So arrowhead to indicate the line extends forever, left and right, up and down. Label those axes x and y, and give our scale. Let's also jot down our label. We could label it as y equals negative 3x plus 10. Or you could give it the label of its original form, 3x plus y equals 10. Because they're the same equation, we did change its appearance by solving for y, but they're representing the same equation, the same relationship between x and y. Here's our next example. Graph the equation 2x plus 3y equals 18. And we will take the approach where we first solve this equation for y, and then make a table of ordered pair solutions. To solve for y, we need to get rid of everything else on this left side of the equation. First, moving the term 2x with minus 2x both sides. It gets that 2x off the left side, and we know with an equation we have to keep it balanced, so negative 2x or a minus 2x on the right side also. So now we're looking at just the 3y on the left side, but the negative 2x and positive 18 are on the right side. Be careful that we don't want to ever combine terms when one has a variable and the other just has a number. They'll need to stay as two separate terms. And we're starting to embrace the habit of putting the x term first. so negative 2x, and then plus 18 because this is a positive 18. Now we're not solved for y yet because this term is 3y, 3 times y. So there's one more step to solve for y. Undo the multiply by 3 with a divide by 3. The way we'll need to do it on this right side is to be sure that we divide every term by 3. We're used to saying that this step is once per side, or once on each side. Whatever you do to the left side, you have to do to the right side. So technically this is what we're doing, but a rule about fractions is that if we have several terms in the numerator and only one in the denominator, it means that each of these terms is being divided by 3. For sure, negative 2x plus 18 divided by 3 is what we have, but it does mean that each of these terms is being divided by 3. So we'll be in the habit of saying each term we're dividing by 3. That is how we accomplish dividing by 3 on both sides of the equation. We know that we'll isolate the variable y. It will not divide evenly here with the x, so we'll keep it as a fraction, negative 2/3 x. And our third term is positive 18, which does evenly divide by 3, equals positive 6. So the equation that we'll be graphing, y equals negative 2/3 x plus 6. We did have to divide by 3 to solve for y, and that's why we ended up with this fraction. It does not divide evenly with the negative 2, that's the coefficient of x. But that's not a huge deal. We'll not try to make a decimal out of it. We want to keep it as a fraction, so we're looking at negative 2/3 x. Here it did divide evenly, 18 divided by 3 equals 6. Now that our equation is solved for y, we're going to make the table. I've made a little bit of space, but kept that equation solved for y. Y equals negative 2/3 x plus 6. These two equations are the same equation. One is just solved for y, but they represent the same relationship between x and y. And to make a graph of this equation is going to be the exact same line as the graph of this equation. So we're not making any huge changes. Solving for y just gives us a form that is very easy to work with when we want to put numbers in place of x. It's a bit smoother than just dealing with the original equation. So now let's make our table. For the first value of x, I'll be choosing 0. Y equals negative 2/3 times 0 plus 6. We know that multiplying by 0 equals 0. That term is wiped out. We're just left with the positive 6. So we have an ordered pair just on the y-axis when we go up 6. Next, let's see what happens when we choose x equals 1. Y equals negative 2/3 times 1 plus 6. Now we have to do some operations with fractions. Negative 2/3 times 1, it's not too bad because multiply by 1 we know keeps the original number, so negative 2/3. But now we have to add it to 6. So we're looking at getting a common denominator, the 6. If we multiply this by 3 over 3, so a fraction that equals 1, so it's not changing the value, but it will give us that denominator of 3. It becomes 18 over 3. And now negative 2/3 plus 18 over 3 is 16 over 3. As a mixed number, that's 5 1/3. Now, we don't have to deal with fractions when we're looking at an equation like this. That negative 2/3 is unavoidable with this given equation. But there are specific numbers we can choose for x that will allow us to avoid some mess like this as we're working through the middle to find our value for y. And the key is that we want to choose values for x that will evenly divide by 3. That's how we can avoid a fraction in our final answer. So 1 doesn't evenly divide by that denominator of 3, so we end up with a fraction in our answer. But as long as we choose numbers that are divisible by 3, or you could call them multiples of 3, we will stick to integer values. We can avoid fractions. So when we see a denominator of 3, we want to choose x values that are evenly divisible by 3. If our denominator was 5, we would choose numbers that can be divided by 5. That's the way we avoid fractions. There are times when we want to choose some specific values of x to make our arithmetic easier. And seeing a fraction for this coefficient of x means that we want to choose numbers that will evenly be divided by that number in the denominator. Now we'll still be able to see that the ordered pair 1, 5 1/3 is a solution, and it will still be on the line. But because we're trying to make this graph by hand, it's easier if we stick to integer values. So the next x value we'll choose will be something that is divisible by 3. How about 3? Let's keep it simple. So putting 3 in place of x, y equals negative 2 over 3 times 3 plus 6. Now you want to pay attention to how we are evenly dividing. The 3 that we put in place of x, the whole number 3, is like a 3 over 1. So we can see that this multiplication will leave us with just a negative 2 over 1, or negative 2 plus 6. And negative 2 plus 6 equals 4. So there's a nice integer ordered pair, 3, 4. Let's get one more ordered pair solution because I don't want to rely on this one that has the fraction. We'll see how it fits in, but I do want to find one more ordered pair solution. So we'll choose x equal, just as long as it's divisible by 3, so we'll choose x equals 6. Our equation, y equals negative 2/3 times 6 plus 6. Take care of this multiplication, and notice that the 6 will be divided by 3 and leave us with 2. So we have negative 2 times 2, negative 4. And you can really choose your own favorite way of multiplying the fraction by the number we're putting in place of x, but the key is that we see it divide evenly, so that we have a y value that is not a fraction. In this case, when x equals 6, y equals positive 2. So let's plot these other 2 points. 3, 4 over 3 up 4, and then 6, 2. 1, 2, 3, 4, 5, 6, and up 2. It's looking good. Let's connect them with the straight line and wrap up this graph. The line extends forever both ways. Label the x and y axis. Do our scaling. And we can label this line. It's the line 2x plus 3y equals 18. Now we're really able at this point to handle a whole lot of complicated graphing questions with the approach that we've been using so far. If the equation is not solved for y, then let's do that first. Once it's solved for y, we're making a table of ordered pair solutions. Choose some number for x, plug it into the equation, and find y. When we end up with a fraction here, we see how it's helpful to choose x values that are divisible by that denominator. That keeps us using ordered pair solutions that are integers and a lot easier to plot on the graph. So let's do an example with a fraction for you to try so you can get a handle on this approach a little bit better. So here's the problem for you to try. Graph y equals 2/5 x minus 1. It's already solved for y, so that part is taken care of. We're ready to go right into our table. You'll just want to be cautious about what numbers do we choose to use for x. 0 is still going to be a good start, but what other numbers would we use? Make sure that our denominator will evenly divide those values that we put in place of x. So pause the video to try this one, and now you can restart. We'll go through the answer together. Here's my table, and I'll first choose x equals 0. Y equals 2/5 times 0 minus 1. So that's a 0 minus 1 equals negative 1. Next, I'm choosing a number that is divisible by that denominator, 5. So I'm choosing x equals 5. Y equals 2/5 of 5 minus 1. And 2/5 times 5 equals 2 minus 1. The 5 and the 5 divide out. 2 minus 1 equals 1. There's another ordered pair solution. For the third ordered pair, I'm still choosing a number that is dividing by the denominator 5. So I'm going up to x equals 10. Y equals 2/5 times 10 minus 1. The 10 divided by 5 equals 2. So we're looking at 4 minus 1 equals 3. There's another ordered pair solution at 10, 3. Now we're getting very close to the edge of our plane here, but I'm preferring to choose numbers that are dividing by the denominator. But I want to point out to you that if we're starting to get close to the page or off of the page, negative numbers will work also. If I want to use numbers divisible by 5, negative 5 is another good choice. And now I'm back more in the middle of the page and not close to the edge. And this is a good strategy if you're trying to plot points that are going to put you off the paper. Think about negative values. 2/5 times negative 5 minus 1. Now careful here, 5 and negative 5 dividing, but it's going to leave us with 2 times negative 1, or a negative 2 result of this multiplication. And then negative 2 minus 1, negative 3. So we had to be a little bit cautious with working with the fractions and also operating with these negative numbers, but that gives us another ordered pair solution at negative 5, negative 3. Now we'll plot those points, see that they line up in a straight line, and connect them with the line. That will be our graph. We've got 0, negative 1, so horizontally 0, but down 1. We have 5, 1, over 5, up 1. 10, 3 was right at the edge, over 10 and up 3. And the last point, negative 5, negative 3. So back 5 and down 3. And still the points are lining up on a nice straight line. So we'll wrap this up with some labeling. And here's our graph of y equals 2/5 x minus 1. Here's one more example for you to try. So pause the video, go through our steps of solving for y and then making the table, and now we'll look at the answer together. To start off solving for y, I need to get rid of this x term, taking away 3x. Leaves me with, careful here, negative 4y, and on the right side, negative 3x plus 16. A quick reminder that 16 minus 3x is no problem. It is equivalent, but we are in a habit, for something that we'll see in the future, of writing the x term first and the constant last. So just bear with me while we keep doing it this way. One more step to finish solving for y, divide everything by negative 4. We definitely needed to divide by negative 4 because this term is negative 4y. To solve for y, we need to have it a positive y. Now again, we have a situation where we're not dividing evenly, we just want to write a simplified fraction. So a negative 3 over negative 4 would be a positive 3/4. The constant term does divide evenly. Positive 16 divided by negative 4 equals negative 4. So here is our equation solved for y. And now we'll make the table. Here's the table. I've squeezed the equation right into my middle space. The first value of x, I'll choose 0. Now the equation is y equals 3/4 times 0. We know that equals 0. And a minus 4 in our equation leaves us with y equals negative 4. There's our first ordered pair solution, horizontally 0, vertically down 4. Because this equation left us with a fraction for our coefficient of x, I'm going to choose x values that will evenly divide by this denominator 4. So my next x value is 4. Y equals 3/4 times 4 minus 4. 3/4 times 4 equals just 3, and 3 minus 4 equals negative 1. When x equals 4, y equals negative 1. Next is another x value that is evenly dividing by 4. I'm choosing x equals 8. Y equals 3/4 times 8 minus 4. Remember, if it's helpful, we can always write that 8 as 8 over 1 because we're multiplying by a fraction, but we're really interested in how is it evenly dividing by that denominator. So 8 divided by 4 equals 2. We're left with 3 times 2, 6 minus 4. And 6 minus 4 equals 2. But again, however you choose to find 3/4 times 8, go for whatever way you like. But we should end up with 6 as a result of that multiplication, and then 6 minus 4 equals 2. So our third ordered pair at 8, 2. The points are lining up nicely, so we're connecting them with the straight line. And there's the graph of our equation. Labeling the axes and our scale, and then writing the equation next to our line as the label. There is the graph of 3x minus 4y equals 16.